Good afternoon, everyone. We're basically just going to finish the note from yesterday. So we only have two more examples to do, and then we're just going to assign some practice work, and you're going to have hopefully quite a bit of time to work on that in class. Okay. So here's our first one. If sine of A is negative 4/5 and A is between pi and 3 pi over 2, and cosine of B is negative 5 over 13, and B is between pi over 2 and pi, we're going to evaluate the value of tan of A plus B. Okay. So first thing to note here, okay, is we did a problem like this, I think a couple days ago when we started moving into the section of trig, right? The information I have for sine and cosine is going to allow me to draw a little picture so I can figure out tan, right? Because the formula, right, tan of A plus B, I'm going to need to know tan of A and tan of B if I want to do that fairly quickly here. Okay, so we'll start with A. Okay, so it says sine of A is negative 4, 4, 5, and A is between pi and 3 pi over 2. So we know then that our angle, okay, right, is going to be somewhere down here. So this is my angle A. Okay, in terms of my triangle, so we'll draw the related triangle here. Okay, the negative 4 would be the vertical part. Okay, that's my opposite side. And the 5 is the hypotenuse. Okay, so we need to find the remaining side. Okay, right, we would use Pythagorean theorem to find the remaining side. Okay, we've done Pythagorean theorem lots, so I don't think I need to go through those steps. Okay, so for the opposite side of that, sorry, not the opposite, the adjacent side of that little triangle, that's going to end up being negative 3, right? 3 squared plus 4 squared is 5 squared, and it's negative because it's on the left-hand side of the axis there. Okay. Again, why this is going to be useful is because in a minute when I start to work on tan of A plus B, I can say that the tan of A is equal to, right, my opposite over adjacent. So it's negative 4 over negative 3, or just 4 over 3. Okay. So there's my first one. Okay. My second expression, okay, I had cos of B is negative 5 over 13, and I am in the second quadrant. Let me just double check. Yeah. Okay, so for my second angle, right, it's going to be something like this. I know it's not really to scale. There's my angle B. Okay, and if we draw the triangle that goes with that, okay, it was cosine. So the negative 5 is here. And the 13 would be here. Okay. And again, if we run through Pythagorean theorem, we're going to find the other side is 12. Okay. So that means that tan of B, again, is opposite over adjacent. So I'm going to have negative 12 over 5. Okay. So now that I've got both of those values for tan, okay, we're going to look at tan of A plus B. Okay. So from our formulas from yesterday, okay, what is tan of A plus B? Well, that is tan of A plus tan of B over 1 minus tan A tan B. Okay, but I know what those values are now from looking at those other ratios. So we had tan of A was 4/3. Okay, tan of B is -12/13. No, wait, that was 5, wasn't it? 12/5, pardon me. Okay, in the denominator, I have 1 minus 4/3 times -12/5. Okay, so now I'm going to start cleaning this up a little bit. Okay, in the numerator, I'm going to need to get a common denominator, which would be 15. So I'm going to have 20/15. Okay, and then I have minus 36/15. Okay, and then it's all over 1 minus, well, let's see, we have a negative there. So I guess this is really going to turn into 1 plus, and 4 times 12 is 48/15. Okay, and the numerator, I'm going to have -16/15. Okay, in the denominator, I'm going to add 15 more there, right? So 1 becomes 15/15, so I get 63/15. Okay, so both, I have my double fraction here, they have the same denominator, so those will cancel out, and so therefore this is going to be equal to -16/63. Okay. Our other example, this one is actually going to be a little bit briefer compared to that one. Okay, we're going to use the addition formulas we learned to verify, I guess, or prove, but really verify one of our related angle identities from a couple days ago. So cos of pi plus x equals cosine of minus x. Or sorry, negative cosine of x. Okay, so start with our left-hand side. Okay, because again, we're going to use the fact that we learned that that addition formula. So we have cosine of pi plus x. Okay, so what was our rule for cosine of when you're adding two angles? Okay, this was cosine of the first, right? So cos of the first angle times cos of the second angle. Okay, subtract sine of the first angle times sine of the second angle. Okay, so again, it's just expanding out the formula. Okay. Now, fortunately for us here, okay, two of these things, right, cos pi and sine pi, those are things we can actually just look up on the unit circle, okay, and I don't have to leave them there. So if we look up cosine of pi in the unit circle, it is -1 times cos of x. And if we look up the sine of pi on the unit circle, sine of pi is equal to 0 sine x. Okay, well, -1 times cos x is negative cos x, and 0 times sine x goes away, and we're basically done, right hand side. Okay, so you could do this if you wanted to for any of those related and correlated identities. It's just, run them through the addition formula or subtraction formula, depending on the setup, and you'd be able to verify, once again, that those things are true. Okay, so that's the rest of the note. So the practice work I would like you to work on, okay, starts on page 232. So questions 3 and 4 to 7a, those are really related to that one example we did yesterday, okay, with like breaking up an angle and using the addition formula. Okay, and 8 to 11 are pretty much the same as the one that we just did, like it's related to that kind of stuff. Okay, so thank you for watching. Okay, enjoy your work time, get all that homework done, so we're ready to go for the next thing when I see you tomorrow.